non-metals. There are metals. Metals are
Which hashtag using which? Mose? Mose already Paul and is using. All there. It states that the physical and chemical properties of the elements are the periodic functions of their atomic masses, right? Atomic masses. And he arranged the elements according to increasing atomic masses, right? Increasing atomic masses. You can see here. What is the atomic mass of hydrogen? Whatever this, why is it making me angry? 1.008. What is that? 1.008. Yes, it's atomic mass is here. Atomic mass of lithium 6.939. It means in his time there were no invention of some elements like helium. Beryllium, what is the atomic mass? 9.012. Boron, carbon, nitrogen, oxygen, fluorine. They have given like this, right? So atomic mass is never a whole number. It is a decimal number. But while calculating, we use that whole number so that our calculation will be quite easier one. Isn't it? To make our study easier, we do. This is periodic table. Periodic table is a table which contains groups and periods. What does it contain? Groups and periods. So elements are kept in group and period either according to increasing number, increasing atomic number or increasing atomic mass. Okay? If the elements are kept according to increasing atomic mass, that is Mendeleev's periodic table. And if the elements are arranged according to increasing atomic number, that is modern periodic table. This thing we have to remember. And some merits of features of the modern Mendeleev's periodic table. And next one, merits of Mendeleev's periodic table we discuss, right? And in today, I think children are going to discuss about the merits of Mendeleev's periodic table, then entry of Henry Moseley, modern periodic table. You have to remember modern periodic law also, features, advantages also, and some problems are there still in modern periodic table. What other things are there? The person who is going to present today is going to explain. Whose turn is it today? Luniva, Manandhar.
As you all know, it's Luniva, Manandhar, standing in front of you to give a presentation on the topic of classification of elements, demerits of Mendeleev's periodic table, position of hydrogen. Hydrogen was placed in group 1 with alkali metals like lithium, sodium, etc. But it could be also placed in position of halogens. Anomalous pair of elements. Certain elements of higher atomic mass or weight were placed before the elements with lower atomic weight. Separation of similar but grouping of certain dissimilar elements, but certain chemically but dissimilar elements have been placed in same group. Position of isotope are the atoms that have the same atomic number but different mass numbers due to the change in the number of neurons. The position of isotopes should be separated according to Mendeleev's periodic table. Lanthanides and actinides. There were no suitable places for lanthanides and actinides series. Modern periodic table. In 1913, Henry Moseley in England provided the details that atomic number is more fundamental property for classifying elements than atomic mass. This is quite reliable, but the chemical properties of the element depend on the number of electrons in the atom, which in turn depend on the atomic number. That led to state the modern form of periodic law. The modern periodic law states that the physical and the chemical properties of elements are periodic function of the atomic numbers. The chart created by the ele- arranging elements in the order of increasing atomic number is called modern periodic table. Advantages of modern periodic table. Isotopes of the same elements share identical atomic number, ensuring they occupy corresponding or same position in the modern periodic table. The placement of hydrogen remains a challenge due to its dual characteristics in group 1 and group 17. Position above alkali metals in group 1 due to similar electronic configurations. Hydrogen, however, it is not classified as an alkali metal, making it a unique element. The modern periodic table consists of 18 groups numbered continuously from 1 to 18. This sequential numbering enhances the specificity and ease of studying elements with the group as property vary with different groups. It effectively segregates metals from non-metals and distinguishes representative representatives elements from tran- trans- transition elements. This is the modern periodic table proposed by Henry Moseley. Thank
Thank you very much. So, Acharya, why Acharya? Our sitting Acharya is fine. This table was made by Niels Bohr. Niels Bohr, but arrangement was done by Henry Moseley. Henry Moseley was British scientist. He gave law in which year? 19. In which year he has given the law? 1913 AD. In 1869, Mendeleev gave the law. In 1913, Henry Moseley gave the law, and they prepared the chart differently, right? So, which chart is more complicated? Mendeleev's chart is more complicated because in one group, two elements are kept, but here in one group, only one element is kept. In one box, one element. Over there, one box, sometimes two also were kept. Sometimes there were vacant space also. So, anyway, D.I. Mendeleev, he started the systematic classification. That's why he is called father of periodic table. And there were some merits. Because of Mendeleev, other scientists were eager to find out or discover new and new elements. And Henry Moseley also was inspired from him. That's why he did the works, right? So, what things are here we have to see? Demerits. Mendeleev's periodic table has got advantages as well as disadvantages. These are disadvantages. Number one, position of hydrogen. Position of hydrogen. Hydrogen is metal or non-metal? Non-metal. But it can be kept in group metal also, non-metal also. So, wait a second. Not fixed. Anomalous pair of elements. It says elements with higher atomic mass, they were kept earlier than lower. For example, I will show you here. Um chlorine, calcium, gallium, tin, uh, potassium. What is the atomic mass of potassium? What is the atomic mass of this calcium? 40. This is more than one actually. So next one also let's see here. Here must be something whose atomic mass is more. Okay, here is no argon. What is the atomic mass of argon? Atomic mass of argon is 40. Atomic mass of potassium is how much? 39. But argon is placed earlier than potassium. That is the problem. Other next one, potassium, calcium, cesium, titanium, vanadium, chromium, manganese. I think they have not kept here. Here also. What the atomic mass of vanadium? 50.94. Atomic mass of the chromium? 50.20. See, the element with more atomic mass is kept earlier, less is kept later. That is also the problem, right? So what is said here? Elements with higher atomic mass was kept later and lower was kept earlier. Elements with similar characteristics were kept differently and different characteristics were kept together. That is also a problem. Here is the next item to remember, isotope. What is given? What do you mean by isotope? What do you mean by isotope? Isotope means atom of same element. Atom of same element with different atomic mass. If I write here 1H1, 1H2, 1H3. Here are three atoms of hydrogen. This is hydrogen. This is also hydrogen. This is also hydrogen. Are here three hydrogens or not? So, which number is mentioned here? That number is atomic number. What is that? Atomic number is same. But here atomic mass is how much? 1. Here 2. Here 3. So, what is the atomic mass of hydrogen? 1. Here 2. Here. Then where to keep this? There was no position to keep these isotopes. For example, C12 and C14. Two type atoms of carbon can be formed. C12 means atomic mass is how much? 12. C14 means atomic mass is 14. Then same atom is there, right? Same element. Where to place? Because they are kept according to atomic mass. So his idea was flop here also, right? So all elements, they don't have isotope. Few elements have isotope. I just said hydrogen, carbon, chlorine, uranium. There are some atoms which contain, some atoms contain less number of neutrons, some contain more number of neutrons, but atomic mass differ or not. So they didn't get suitable position. Next one is lanthanides and actinides. Children, look at here. Here is one table where you can see it. Oh, hot presentation contains the periodic table. It was very lovely periodic table. See here. This is periodic table, model periodic table, and here you can see upper rows also, upper place, and down here are some elements. What is the beginning of this row? La, Ce, Pr, Nd, Pm, Sm, Eu, Gd, Tb, up to Lu. Lanthanum to lutetium. What is name? Lanthanum to lutetium. And here, actinium to lawrencium. These all elements, please you make your concept clear, eh? These all elements, these are called lanthanides. These all elements, they are called actinides. Those elements from lanthanum to lutetium are lanthanides. Actinium to lawrencium are actinides. These all elements have similar physical and chemical properties. So there was no position for them also. Actually, this lanthanum lies here. It lies here. All 57 to 71 mean how many are there? 14 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Means after actinium or after lanthanum there are 14. So elements from 57 to 71, lanthanum, atomic number 89 to 183, actinium. There was no position for them. That is the demerit of Mendel's periodic table. If so, there was entry of Henry Moseley. Where was he from? Henry Moseley. He was from England, and in 1913 AD, he gave one law. That law is called modern periodic law. What is the law called? Modern periodic law. What does modern periodic law state? The physical and chemical properties of elements are the periodic functions of their atomic number. If elements are arranged according to increasing atomic number, after some interval, elements with similar physical and chemical properties can be found, right? So, only one word was changed, no? Mass and number. What does Mendel's periodic law state? The physical and chemical properties of elements are the periodic functions of their atomic mass and modern number. The physical and chemical properties of elements are the periodic functions of their atomic number. And how do you define modern periodic table? Table or chart created by arranging elements in the order of increasing atomic numbers. If that table is made by using the elements according to increasing atomic number, that is called modern periodic table. Here are some advantages of modern periodic table. Number one, there is no problem for isotope because isotope they have got same atomic number. If same atomic number, they are kept in same group, right? Same place. And hydrogen is kept in group 1A. Where is it kept? Because its electronic configuration is similar to 1A. That means its electronic configuration is 1s1. What is that? 1s1. Later on we will discuss about electronic configuration like 1s1 or s2, 2s1, 2s, 2p2, 3s1 like that. What is s? What is p? What is d? This system was given by German scientist Wolfgang Pauli. What is the name? Wolfgang Pauli. And that is called Aufbau principle. Aufbau principle. AUF BAU. Bau principle. So we have to learn and practice later. How are the elements scattered in an atom? How are they distributed? Whether they are found at same place or different places, that will be discussed later on. So even though hydrogen is a non-metal, it is kept in the group of metal because electronic configuration is similar to metal. Okay, it also can lose electron. It also becomes positively charged. So how many groups are there in modern periodic table? 18 groups. And how many periods? 17 periods, right? 17 periods. And it also separates metals and non-metals. Metals are kept in left hand side, non-metals are kept in right hand side. In between metals and non-metals, there are metalloids, right? I think this Luniva's table is very lovely. We can see here once again. When you see this one, suppose here is one PT, isn't it? The PT means name is symbol. At the top it's an atomic number. Down, atomic mass and name. Okay, children. Group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. They all are metals. What are they? Then 14, 15, 16, 17, 18, they are non-metals. But some elements of 14, 15, and 16, they are metals. It's given here. Alkali metal, 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 metal. Oh, here is halogens. Oh, here non-metal, halogen, noble gas, lanthanum, actinium. This lanthanum and actinium, these are also metals. Out of 118, near about 96 are natural. No, 92 are natural. Near about 96 are metals. Near about let's say 18 are non-metals. Then 4, 5 are metals. See, so which are non-metals? We can check here. Non-metal, non-metal, non-metal. These all are these all are non-metals, and these are how many metals are here? 1, 2, 3, 4, 5, 6, 7. Non-metals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, and 20. 26 are metalloids and non-metals. Rest of others are metals. Okay? These things you have to remember, and remaining will be discussed the day after. Today, how tomorrow? Tomorrow day is class. What is it day after tomorrow? Day after today. Remember, day after today is no class. Finish. Holiday. Teaching learning objective is holiday. Enjoyment start, right? So, Buddha is very happy now. Oh, Buddha and children, they got a connection. Which one? Morning class. Morning class, who said holiday?